Hi guys, welcome to 12.4 Sample Spaces. A set of all possible outcomes from an experiment is called sample space. Moving to right here, you can use a tree diagram or a table to show the sample space for an experiment. The tree diagram below shows the sample space for spinning the spinner, so old-fashioned Candylands, flick the spinner, or tossing a coin, heads or tails. The spinner has three choices. You can either spin a 1, a 2, or a 3. And then like a normal coin, when you flip a coin, you only have two choices, heads or tails. And then this diagram right here is called your tree diagram, and they outline all of your possible choices. So just looking right there, you either spin a 1, a 2, or a 3. Let's say you spin 1. All right, so you've spun a 1. You flip your coin. You're either going to get a heads or a tails. Let's say you spun your spinner and you spun a 2. All right, you already have that 2. Now you're going to flip your coin and you're either going to get heads or tails. Let's say you spin a 3. Well, you still have the same chances of getting a heads or a tails. So your tree diagram represents every option. Spinning a 1, getting a head or a tails. Spinning a 2, getting heads. Spinning a 2, getting a tails. Spinning a 3, getting heads. Spinning a 3, getting a tails. It just maps out every choice. There are 6 possible outcomes. Spinning 1, getting a heads. Spinning 1, getting a tails. Spinning a 2, getting a heads. Spinning a 2, getting a tails. Spinning a 3, getting a head. Spinning a 3, getting a tails. Here's the question. What's the probability of spinning a 3, so spinning a 3, and tossing heads? So spinning a 3 and getting a heads. There is only one favorable outcome, and that's, again, your 3. Oh no, I circled the wrong one. There we go. Only one favorable outcome, spinning a 3 and getting a heads, and it's this one right here. The possibility is 1 out of 6, so please forgive me. Pretend I did not highlight that one. But this is our favorable outcome out of how many total? 1, 2, 3, 4, 5, 6. So 1 out of 6. That's called our counting principle. Or not our counting principle, our tree principle. Before we move on to the counting principle, we're actually going to jump down and do this one on the reteach together really fast as a second example. Complete the tree diagram to show the sample space. Rolling a number cube and tossing a coin. So again, a dice has 6 possible options. You can roll a 1, a 2, a 3, a 4, or a 5, or a 6, and they've labeled that here. So how many options do you have when you roll a dice? You have 1 through 6. Second, you're going to toss a coin. How many options for if you toss a coin? You have 2. You have heads or tails. So I'm going to fill that in here. Let's say I rolled a dice and I got a 1. Well, I could either get a tail or a head on my coin. T or H. And that's going to repeat all the way down this road. Well, what are the chances of spinning a 2? And then what are the chances of spinning a 2 and getting tails or getting heads? Or rolling a 3 and flipping a tail or a heads. A 4, a tail or a heads. Tail, heads, tail, heads. And again, by doing this, it marks every single possible outcome on this bottom line. 2 and a 1 and a tail, a 1 and a heads, all the way down to what's the chance of getting a 6 and a tail or a 6 and a head. What is our total number of possible outcomes? The total number of possible outcomes is this bottom line and every single space in it, because these lines represent all possible dice rolled combinations and all possible coin flip combinations. Because again, this tails goes to that 1, this head goes to this 1, this tail goes to a 2, this head goes to a 2. So everything is included. So how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 possible outcomes. What's the probability of rolling a 4, so find your 4, and getting a heads? Right here. Spinning a 4, flipping a heads. Well, there's only one possible option, so one favorable out of every total option, which is 12. I have a 1 in 12 chance of doing that. and that is called using a tree diagram. And now we're going to do the same kind of thing, but using the counting principle. 2 options to represent the same thing. You can use the counting principle to find the number of possible outcomes. If there are m, which just represents for anything, it's a variable, if there are m ways of making one choice, and n, which is another variable, n ways of making a second choice, then there are m times n ways of making the first choice followed by the second. Evelyn and Kara are planning to go skating or to a movie. Afterwards, they want to get pizza, tacos, or cheeseburgers. How many possible choices do they have? There are 2 choices for an activity and 3 choices for food. Choice 1 for the activity is going to go skating. Choice 2 is a movie. So there are 2 choices for an activity. So there are activities, 2 choices, skating or movie represented here. There are 3 choices for food. They're either going to get tacos, pizza, or cheeseburgers. So their second choice has 3 options, if that makes sense. Multiply them together. 2 times 3 is 6. They have 6 choices. And again, you could make a tree out of it. You could say, okay, they're going to go skating or they're going to go to the movies. Skating, movies are their first activities. And then they're either going to get pizza, tacos, or cheeseburgers after they go skating, or they're going to get pizza, tacos, or cheeseburgers after they go to the movies. How many choices? 1, 2, 3, 4, 5, 6. Both bring you back to the same thing. All right, to exercise our counting principle, we're now at the bottom of reteach. There are 4 kinds of yogurts and 8 toppings. Well, how many choices do we have in our first one? 4. Multiplied by however many choices we have in our second, which is 8. 4 times 8 is 32. So we have 32 choices total. We have 6 shirts and 9 pairs of pants. How many combos of outfits can you have? Well, multiply your number of first choices by your number of second choices. We have 6 shirts times 9 pairs of pants. That means we have a grand total of 54 outfit combinations. So now, none of you can tell your parents you have enough clothes. Because if you have 6 shirts and 9 pairs of pants, that means you have a total of 54 total outfit combos. 3 types of sandwiches and 3 flavors of juice. Well, if we have 3 types of sandwiches being combined with 3 different kinds of juices, we have 9 different meal options. Number 5, we have 4 types of bread and 6 different kinds of sandwich breads. Well, if we had a different bread for a different sandwich bread repeated, we would have a total of 24 different sandwich possible combinations. All right, with that, you are welcome to start your homework, but when you do start your homework, number 1 is optional. You can skip number 1 because it has a whole different way of showing counting spaces right here. You're welcome to try it, but you can also skip it. No harm, no foul. All right, guys, good luck.